Assalamualaikum and hi guys. So I hope you guys have watched the video that I've uploaded in my Google site. So in that video, it explains about buoyancy, what is a buoyant force, and what causes the buoyant force, and the Archimedes principle, and which body is floating, which body is sinking. Alright, so in this video I will explain on the equation and all the definition, and also do one example on a buoyant force. So by definition, a buoyant force is the vertical force on a body immersed in a stationary fluid. So if you can see here in the slide, this is the equation to find a buoyant force. So a buoyant force is equal to the weight of the displaced volume. So the weight of this displaced volume is mg. So m is mass. So mass is equal to density times volume. So density times volume times gravitational acceleration. So the volume is the volume of the displaced water or the displaced fluid. So a buoyant force acts through the centroid of the displaced volume. So this point is called as center of buoyancy. So let's do the example. So we have a metal part which is put as 2 here, and the metal part is hanged by a thin cord from a floating wood block. So this is the wood block, the white color. So the wood block has a specific gravity of 0.3 and dimension of 50 times 50 times 10 millimeters. So sometimes for a lightweight solid like wood block here, we can also use specific gravity to find its density. So the metal part has volume 6,600 millimeter cube. So find the mass m2 of the metal part and the tension in the cord. Okay, so as you can see here, I'll do it here. Okay. Alright. So the first thing that you need to do is to draw the free body diagram. So for the wood block, has weight, so the weight is going down. Okay, and at the same time, there's also buoyant force. So this buoyant force is going up, okay, to ensure that the wood is floating. And then for the metal part, I forgot about the tension. Okay, for the wood block, we also have tension. Okay, so this tension is also going down. Okay. All right, for the metal, we have tension going up and also buoyant force. So this buoyant force must not be the same as the previous one because it is only for the metal. Okay, this one is only for the wood. And we also have weight going down. So this is weight of the wood. Okay, and this is weight of the metal. Okay, I put 2 here. Alright, so you need to find the tension and also the mass of the metal part. We solve for wood block first. So the summation of force is equal to 0. So FB equals to weight, FB1 equals to weight plus tension. So basically tension is FB1 minus weight 1. So FB1 is the buoyant force for wood. So we have the equation that I've just mentioned, rho GV, where the V is the volume of the displaced water. Alright, so the water is at 15 degrees C. Okay, we need to get the density. Okay, the density of the water at 15 degrees C. So basically the density of water at 15 degrees C is about 999, and G, gravitational acceleration. So the volume of wood, okay, the wood is not fully immersed in the water. So you need to only consider the part that is immersed in the water. So the part that is immersed is 50 times 50 times, so it's not, the height is not 10, it's 10 minus 2.5. Alright, so 10 minus 2.5 is 7.5 millimeters. So the volume is 50 times 50 times 7.5. So since it's in millimeters, so you have to convert it to meter, times 10 power of negative 9. Alright, so you should get the answer. You can calculate. Alright, the answer is 0.184 Newton. And for the weight of the wood block should be the whole wood block. So since we have specific gravity here, we can use specific weight times volume. So this volume is the volume of the whole wood block. So this one is the specific weight of the wood block. So you can use SG. Okay, so SG times specific weight of water. Okay, this is water, this is wood block. Alright, and then we use the volume of the whole wood block. So 0.3 times 9.8. So this is the value of specific 9.8 times 10 power of 3. So this is the value of gamma of water at 15 degrees C. Okay, so the whole volume is 50 times 50 times 10 times 10 power of negative 9. So the answer should be, calculate. Okay, so 0.0735. Okay, Newton. Right, so therefore we use back this equation, tension is equal to 0.184 minus 0.0735. So the answer should be 0.1105 Newton. Okay, all right, so this is for the tension, and then the question asks for the mass of the metal part. So I find the weight first, then later we find the mass. So we do the summation of force for the metal. So we have T plus FB2 is equal to weight 2. Okay, so since we want to find M2, so we put it this way. So therefore, we already got the tension here. Then we find the FB2. So FB2 is equal to gamma times, you can actually use gamma, or in this case I use rho g, so I just follow the same formula. Okay, so this should be water. Okay, then this should be water as well. Alright, and this is the volume for metal. So metal is fully immersed, so the whole metal volume should be included. So 999 times 9.81 times 6600 times 10 power of negative 9. So you calculate, you should get 0.0647 Newton. Alright, so you rearrange this equation. Okay, M2 is equal to T plus FB2. We divide by G. So T is 0.1105 plus 0.0647. Then you divide by 9.81. So the answer should be try to calculate. So the answer should be 0.0179 kilogram. So if you convert this to gram, 1, 2, 3, so it's about 17.9 gram. Okay. Alright, so the mass of the metal is about 17.9 grams. Okay, so this is how you solve the question that involve buoyant force. Okay, so that's it for this video. I hope you guys understand. So thank you.